Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Achievers. Okay, so in the previous class we have discussed about the Newton's first law as well as we have discussed Newton's second law in details. And if you are watching this video and if you have not watched the previous video, please do watch the previous videos to understand the next videos or the upcoming videos in a better way. Okay, so without wasting much time, we will be directly moving on to our topic. Today we are going to discuss about some applications of Newton's second law. Okay, so before discussing about those applications of Newton's second law, we can actually relate the Newton's first law to the Newton's second law. I hope all of you have remembered the Newton's first law. We have discussed in details in one of these lectures about Newton's first law, and for those who have not seen that lecture, it will be better for you to just watch that lecture. It will help you to understand the topic in a more fruitful way. Okay, although just repeating it once again, what does the Newton's first law state? That the first law states that whenever an object is in rest, it will try to remain in rest, or whenever an object is in motion, it will try to remain in motion as long as there is no external force applied. Okay, so and as an example we have pointed out that if a book kept on a table, it remains at that position until you apply a force by your hand and move that book, isn't it? So this actually is the basic concept of the Newton's first law. Now what does the Newton's second law? For a special case of Newton's second law, I have seen that for a special case of Newton's second law, you can say that the force is equal to mass into acceleration. This is a special case of Newton's second law. I am again repeating. If anybody have not watched the previous video on the Newton's second law, please do it, watch it carefully. You will be able to understand this. Okay, so this is one of the particular forms of Newton's second law. This is not actually Newton's second law in general condition. Okay, so using this particular case of Newton's second law, if we say that the force applied on a body is zero, okay, if we say that the force applied on a body is zero, now if the force applied on a body is zero, then definitely mass cannot be zero, mass of body cannot be zero, then definitely the acceleration will have to be zero, isn't it? So what does this indicate? That if you are not applying any kind of force on a body, external force on a body, what happens? Actually there is no acceleration in the body. There is no acceleration in the body. Now what does that mean? If there is no acceleration, definitely the state of the object will not change. Object which is in rest will try to remain in rest. Object which is in motion will try to remain in that particular motion, or will continue to move at that particular velocity. Okay, so basically this is the Newton's first law, isn't it? That until and unless an external force is applied, there will be no acceleration, and if there is no acceleration, certainly we can say that the object will not change its state, either be it of rest or be it of motion. So this is basically how you can relate the Newton's first law to the second law, or you can explain the concept of first law using the second law. Fine. Now let us discuss about some of the applications of Newton's second law. Okay, so the fact that we have considered is that Newton's second law, okay, so the second law basically states that the force applied on a body is nothing but is equal to the rate of change of momentum, isn't it? This is the main thing. Fine. Now where we can actually get an overview of this force, this is actually, these are many wide range of applications. Okay, so first of all we are going to consider an example of a particular situation in a cricket match. Many of you have played cricket or must be playing cricket till now also. So you have experienced that when you catch a ball, okay, if a ball is hit hard by a batsman, and if you directly catch the ball, or that ball is falling from the high up in the sky, it is falling from a very large height, and it falls on your hand and you catch the ball, you suddenly feel that the ball executes a certain force on your hand. So why does it feel like that? Okay, see, when the ball is moving, it has a certain momentum. Okay, when the ball is moving, it has a certain momentum. So initially when the ball is just falling from the sky, it has a certain initial momentum. So let us consider it to be pi. So it is basically mass into velocity of the ball at that instant. Okay. Now when you catch the ball, what happens to this velocity? When you catch the ball, what happens to this velocity? The velocity becomes 0, isn't it? Now, so the final momentum can be considered to be 0 because the velocity of the ball turns out to be 0. So this change in momentum must have occurred in a certain specified time. Okay, and just think of the condition that a fielder or you yourself think of the situation, you are in that condition and you are catching a ball, or if anybody has not played cricket, at least he or she can imagine the situation that when a fielder or when a person just catches the ball, what happens? The ball comes to rest within a very short span of time. Okay, so the change of momentum that is occurring, that is occurring here, that is equals to Pf minus Pi. This change is occurring in a very short interval of time. So delta t, by delta t we have discussed that delta indicates the change. Okay, so delta t, basically what happens, this delta t is very small, this is very small. Okay, so if I just consider the fact this change in momentum by delta t, so the delta t is in the denominator portion, and you know in case of fraction, if the denominator is very less, obviously the value of the fraction will be quite high. Okay, so in this case try to remember that if the time interval within which the momentum is changing is very small, okay, so overall the rate of change of momentum will be very high, and as you know, as you can see, if the rate of change of momentum is very high, what happens, it shows that a large force will be exerted. So basically a force is being exerted on the hands of the fielder. Okay, fine. Now another example you can talk of is that if you think of a glass article. Okay, glass. If you just consider a glass vessel or a glass particular decorative material made of glass, and think of the situation that it suddenly falls from your hand. Okay, if it falls from your hand and it falls on the ground, a hard ground, what happens? It just breaks or shatters into pieces. But you can see, or you can imagine, or you can even try this experiment, that if you just drop that glass material on some cushion, okay, if there is a cushion or there is a much thick layer of sponge, and if you drop that glass article or glass decorative material on that cushion, in that case it does not seem to break. Why? See, in case when the glass falls on the hard floor, okay, the glass falls on the hard concrete floor, okay, the glass article, say suppose this is a glass article, it just drops and strikes the surface of the ground, okay, it immediately comes to a stop. As in the case of the fielder who is catching the ball, if he just keeps his hand still at a steady state condition, at a just fixed position, and he catches the ball, he doesn't move his hand, then the ball immediately comes to rest in a very short span of time. Okay, so in this case also that happens, and if that span of time is very short, the change of momentum that is taking place is within a very short interval of time, so the rate of change of momentum is very high. Thus a high force or a large force is exerted on the glass material and it suddenly shatters into pieces. So like is the case of the fielder catching the ball, if he or she, that person does not move his hand, what happens when he or she moves his hand a little bit while taking the catch? If we just consider like this, the ball has been caught like this and just moves the hand a little bit downward, what happens? When he is moving the hand downward in the direction of the ball, definitely what happens, the ball does not comes to rest immediately or in a very short period of time. That when the person is just moving his hand a little bit down, certain that the time interval within which the momentum is coming to zero, it increases even a slight, and that slight increase in time interval is enough for the denominator to increase by a certain amount, and that causes the rate of change of momentum to become low or become less. Thus the force exerted on the hand of the person catching the ball will be less. Same is the case in case of this glass article falling on a hard concrete floor, it shatters. But when it falls on a sponge, okay, or in a very say soft land, okay, on a soft surface, what happens when it falls on a soft surface? See, when it falls on soft surface, it does not get immediately stopped. Okay, the soft surface gets depressed, something like this. Okay, so the glass article is actually taking some more time to come to a halt. Okay, and this certain amount of more time is enough to increase the time interval by an amount which causes the force to decrease by a certainly quite large value, and as a result what happens, the glass article does not break or shatters into pieces. Okay, so this is why actually if the glass article falls on a soft surface, it does not break. Okay, similarly you must have seen the athletes taking long jump, okay, or high jump. Okay, a high jump, what happens, they land on a bed of sand. Just the same thing is happening. If that athlete lands on a hard concrete ground, what happens, that person is falling from a certain height. Okay, and if he or she falls on a hard land, definitely what happens, he or she comes to rest very quickly within a very short span of time. So the rate of change of momentum is becoming very high, which causes a large force to be exerted on the person, and that person can actually get injured. Either his bones can be broken. Okay, so that is why they land on the bed of sand. Okay, so this is an example. So these are some of the examples where you can see that we are actually applying the Newton's second law in order to change the situation, in order to get less injured, or in order to save a vessel from cracking. See, that is also another application of this law, that when we pack glass articles, what we do, we wrap around some papers. Okay, just crumbling the papers and we just wrap it around. What does that do? That causes certain air pockets to be formed around the glass article. Okay, and that certainly when it is in a package, say the glass article is in a package like this. Okay, and if there are certain paper crumbled around the glass article like this. Okay, so the glass article may be a very small article, say like this, a piece of glass article. So if the papers are crumbled around it, they form some certain air pockets. Okay, so now when this actually packaging, it suddenly falls from the hand or hits a hard surface, the jerk does not actually reach the glass article. The jerks are absorbed in this air pockets. Okay, so what happens, if the jerk does not reach the glass article, definitely the rate of change of momentum for the glass article will not be high, and it will not, a very minimum force will be exerted on the glass article, so that the glass article will not break. So these are few of the applications of Newton's second law, and you can actually apply these laws very if you apply these laws very carefully in your daily life, they are very useful. Okay, fine. So with that we come to the end of the discussion of Newton's second law. In the next class we will be discussing about Newton's third law. Okay, so till then please do study well. If you have any query, mention it in the comment box. We will be happy to solve your problems, queries. Till then, in the next class, do study well. Thank you. Goodbye.